Okay. Yesterday, we have started that third module on that numerical solution of initial value problems. That means when a first order, first degree differential equation is given, how to solve with the initial condition numerically that you have seen. And we have seen at the uh, first set that method of finding that solution using Taylor series method. So how to write a series for a solution set and how to write the solution that you have discussed. And, and just I have given introduction to Euler's method to find the solution of initial value problem. So we shall continue with this method, that is Euler method. So in this method, the concept behind this method is that we approximate the solution curve by a straight line. That means a tangent to the curve at the point where the initial solution is given. So that is the concept behind this. So here what we believe is that when the interval is very small, any curve can be approximated with a straight line. So we write the equation of straight line and define the value of the unknown at a particular value. So this is the theory behind that Euler's method. So how it works, let us discuss. Consider a first order differential equation dy by dx is equal to f of x comma y. That means how the dependent variable y changes with respect to x. It is given as a relation in terms of x and y. Any expression of this type is called first order, first degree differential equation. If the initial condition is given, that is initially the value of y may be given at a particular value of x, then it is called initial solution. That means y of x naught is equal to y naught. The value of y at a point x equal to x naught is given that y naught. Here x is independent variable, y is dependent variable. We need the solution for the dependent variable for any independent at any point of the independent variable. Now, as I told just in this method, that means in Euler's method, the solution curve is replaced by the tangent to the curve at that point. So if you write the equation of a tangent, you know how to write the equation of straight line passing through a point. When you write this one, we get a formula like this. That is, if you want to find a solution at a point x is equal to x naught plus h, let it be x1. That means at x naught solution is known. X naught plus h means that the point where we need the solution must be very near to this initial condition. H means that symbol used for a small change in x. If add to this very near to x naught, then you can find the solution. That means where the curve is approximately a straight line, if that curve is very, very small, under this assumption, we are finding the solution. But it gives only an approximate solution, not the exact answer for that differential equation. So at the point x is equal to x naught plus h, let it be x1, the solution is given by this formula. It is denoted by y1. y1 means value of y at the point x is equal to x1. It is given by, say, y1 means value of y at x is equal to x1. It is given by this formula, y naught plus, y naught means the solution at x naught, the initial condition, this one. For this, we add the slope, because what is f of xy? F of x means dy by dx, but dy by dx always represent slope of the tangent to the curve. So we replace this one by this and multiply by this length h. When you multiply, it gives an approximate answer for this. By knowing the solution at the point x1, we can find the solution at the point x2, where x2 is nothing but x1 plus h. So the solution at x2 is given by y2 is equal to y of x2 is y1 plus h into f of x1 comma y1. Like that, we can continue and we find the solution at the n plus 1th step. That means solution at x is equal to xn plus 1, it is given by the solution at the previous step, that is y sub xn plus slope of this function at that point xn y1. That means h into f of xn comma yn is the general formula. the solutions node at the step x is equal to xn. By knowing this, we can find the solution at the next step, that is x is equal to xn plus 1. This is the iteration formula for that. Right? We shall take one simple example. Suppose that is asked to find the solution of the differential equation. Let it be dy by dx is equal to x plus y with the condition y of 0 is equal to 1 by taking h is equal to 0.1 at the point x is equal to 0.4. So the solution for this differential equation is known at the point 0. When x is equal to 0, it is given. That is given that y of 0 is equal to 1. By knowing this, by this initial condition, that means initial solution, we have to find the solution at the point x is equal to 0.4. So 0 to 0.4, the distance difference is 0.4 is that. But for this method, the value of x must be very small. Then only can give the good answer. Otherwise, won't give the solution. For that reason, it's asked to take h is equal to 0.1. That means go on dividing this interval 0 to 0.4 into 4 equal parts. Because h is 0.1 means first to find the solution at, it is x naught here, at x1. x1 is how obtained? X naught plus h. X naught plus h means 0 plus 0.1 is 0.1 we get. So at x is equal to 0.1, first you have to get the solution. That we let it be denoted by x1. Then x2 means again add 0.1 to this, that gives 0.2, that is x2. x3 is equal to again add 0.1 to x3, sorry x2, 0.2 plus 0.1, 0.3 again. Like that, till we reach this point, you have to divide this x values. So given condition is here, x naught is equal to 0. In order to solve this, first you have to identify what is x naught, what is y naught. X naught is here 0, y naught is 1. Asked to take h is equal to 0.1. So let us take h is equal to 0.1. From this value of h, first see before reaching 0.4, how to divide this. First find the solution at x1. x1 is nothing but x naught plus h, means 0 plus 0.1, it is 0.1. At this point, first get the solution. Then at x2, x2 is nothing but for x1 add 0.1, so 0.1 plus 0.1, 0.2 to get, again 0.2 plus 1, 0.3. Like that you can get the solution up to 0.4. Or I shall restrict this one to 0.3 only, because I have done this problem up to 0.3. Instead of this 0.4, shall make it at x is equal to 0.3. So general formula written, the solution at the n plus 1th point, that means at x is equal to xn plus 1 is given by solution at the previous step plus h time slope of the function, slope of the curve at the point x is equal to xn, y is equal to yn. Slope means f of xn comma yn. So first we shall get solution at x1. So that is denoted by y1. From this formula to get y1, you have to put n is equal to 0. When you put n is equal to 0, it gives y1 is equal to, this is y0 plus h into f of x0 comma y0. Because we're taking n is 0 to get y suffix 1. So n is 1 is y0 plus h into f of x0 y0. y0 is known. y0 is here 1. So write this is 1 plus h. h is asked to take 0.1. So h is 0.1 into f of x0 comma y0. x0 is here 0. y0 is 1. So 1 plus 0.1 into f of 0 comma 1 we get. This is the value of y1. But what is f of x comma y? The problem, it is given that f of x comma y is x plus y. That means f of x comma y means how the variables x and y are related in this problem. So the relation is just sum of the x coordinate and y coordinate. So it is x plus y. So this f of 0 comma 1 is here. For this problem is x plus y means x coordinate plus y coordinate. That is 0 plus 1. So it gives 1 plus 0.1 into f of x comma y means x plus y is written. So it's 0.1 into 0 plus 1. To simplify, it gives 1 plus this much into 0.1 is 0.1, 1.1. This is the solution for y at x is equal to 0.1. Question asked to get the solution at 0.4. So I got the solution at x1. x1 means 0.1. By knowing the solution, you have to go to the next point, because if that length is very small, that curve is approximated by a straight line. So making a small straight lines which are tangent that point, we are finding approximate solution. It's not the exact solution, only somewhat good answer for this problem. So y1 equal. Next, find a solution at x2. x2 means y2. Solution at x2 means y2 you have to find. So how to get y2? y2 is, if you use the formula here, when n is equal to 0, you got y1. When you put n is equal to 1, it gives y2 in the left hand side. So it is y1 plus h into f of x1 comma y1. So y1 is this value, it's 1.1. So write 1.1 plus h. H means again 0.1 into f of x1 comma y1. x1 is here, written here. x1 is 0.1. y1 is 1.1. So it is f of x comma y. F of x comma y means this dy by dx. There is slope. Here, how the slope is obtained? By adding x coordinate and y coordinate. So this is 1.1 plus 0.1 into this is x plus y. That means 0.1 plus 1.1. To simplify this, it is give the answer 1.22. So this is the solution at x is equal to x2, denoted by y suffix 2. By knowing this, let us see what is y suffix 3. Y suffix 3 means the solution at x is equal to x2 or y3. How to get solution at x3 is obtained by seeing the solution at the previous step. That is y2 plus h of f of x2 comma y2. So all these are known. y2. y2 means you know what is the value of y2. y2 is here written 1.22 plus h. h is 0.1 f of x2. x2 means here written 0.2 plus y2 1.22. So this, once you know the relation, you can directly write, no need of writing all the steps like this. So f y2 plus h into f of x2 y2 means y2 you write plus h you write. F of xy is defined as, that is f of x means dy by dx. That is right hand side of the equation, x plus y. That means add these two coordinates. So it gives the answer. So if we simplify, it is 1.36. So next we need the solution at 0.4. That means x4. x4 is nothing but x3 plus h. That means 0.4. So it is y suffix 4 is given by y3 plus h into the slope of the curve at that point. So y3 means here written 1.36 plus h is 0.1. F of x comma y is defined as sum of these coordinates, that's x3 plus y3. x3 is 1.3, y3 is 1.36. Add it, it gives 1.53. This is the solution at x is equal to x4. x4 is nothing but 0.4. So the solution for this differential equation at x equal to 0.4 is nothing but 1.53. But don't think it is the exact solution for this, only approximate answer. So it gives only approximate answer, not exact. So this is old problem. So old problem means that method is very old. So it won't gives actual value. But nowadays number of good methods are available. But since the syllabus is given, you have to write this. So this is Euler's method of finding the solution. We shall take one more example. Suppose that is asked to find the solution of the differential equation dy by dx is equal to y minus x divided by y plus x, with the condition y is equal to 1 at x is equal to 0. What do you mean by this? This represents y of 0 is equal to 1. That means instead of writing y of 0 is equal to 1, it is written in words. The meaning of y of x naught is equal to y naught is the value of y is equal to y naught when x is equal to x naught. This is the condition here. Now, this is the differential equation with this initial condition, and the question is to solve, that means to find the value of dependent variable at x is equal to 0.1. But we can't directly take at x 0 is given, 0 to 0.1 length is h. H we can't take 0.1 because it is mentioned take h is equal to 0.02. Under this condition you have to solve. So for that, when it's asked to solve, first step you have to do is what is the initial condition, what is x naught, what is y naught. First you have to identify these two. X naught means 0, y naught is 1. Next, one thing you have to notice, what is h? H is given 0.02. If it is not given, suppose that h is not given, then you are free to select h. You can take 0 to 0.1, length is h, 0.1. You can take h is 0.1 also, because it is 0.1 is very small number, no problem. But here they mentioned take h is equal to 0.02. So this value is considered. Now, under this condition, see how many steps we need to get the solution at the point x equal to 0.1. Starting point is 0. Add h to this, see what you get. That you call it as x1. So x1 is nothing but here. So before that, let us identify f of xy. F of xy means that dy by dx on the right hand side, that is y minus x divided by y plus x. So now we have to find the solution first at x naught plus h, that means x1. What is x1? x1 is x naught plus h, means 0.02. At this point you have to get the solution first. Then again add h to this, that gives h2, x2. So x2 is x1 plus h, that is 0.04. We have to reach here because question asked is find the solution at the point x is equal to 0.1. In order to reach that, only two divisions over, it's not reached this place. Again take another one, x3. The next point x3 is, that is x2 plus h. If add h to this, 0.04 plus 0.02, 0.06 you get. That also not enough because you have to reach here. So next you shall call it as x4. x4 is x3 plus h. If add it, we got 0.08. Till it is not reached at this point. Again add 0.2 to 0.0 to this. So x3 plus h, 0.08 plus 0.02. If add it, get 0.1. So to get the solution at x equal to 0.1 with h is equal to 0.02, you have to divide that interval into here 4 equal parts. So first one is at x1, that is at this point get the solution. Next find the solution at this point. Next go to this 0.06 and then reach here. That will give you the solution at this point. Now we shall call all the solution by y1, y2, y3, y4, y5. So y1 means the solution at the point x1. So which method you have to use? Euler method. So EULER. Don't read as Euler. It is not Euler, famous mathematician name. We have to pronounce like Euler. Here E is absent there. Euler is the pronunciation of this mathematician. Okay. Now y1 first you shall get, that means solution at the point x equal to x1. But which formula? Here is Euler's method. Euler's method means formula must be remembered. Euler method is nothing but we are replacing solution curve by a tangent, straight line. This is the equation of straight line. How you write equation straight line? Y minus y naught is equal to m into x minus x1. If you substitute it, simplify, we get this form. M means here dy by dx. That's written here. So y naught plus h into f of x naught y naught. Y naught is here 1. H is here 0.02. F of 0, 1. This is the value of y1. But what is f of xy? You have to read. F of xy means how x and y are related. Here x and y are related how y minus x divided by y plus x. So this value is nothing but 1 plus 0.02 f of x comma y. It is related by this relation y minus x divided by y plus x. That means here this is y coordinate, this is x coordinate. So 1 minus 0 divided by 1 plus 0. Just simplify, we get 1.02. This is the value of y1 at that point. Next, by knowing this, go to y2. Y2 means solution at x2. That means we need what is y of 0.04. How to get it? The previous answer we denoted by y1 plus h into f of x1 comma y1. This represents slope here. Okay. So this is nothing but y1. Y1 just return 1.02 plus h is 0.02. F of x1 comma y1. X1 is return x1 is 0.02 comma 1.02. But f of xy for this problem it is related under this relation y minus x divided by y plus x. We use this relation, these two as itself, f of x comma y is y minus x. That means 1.02 minus x, x means 0.02 divided by y plus x, that means 1.02 plus 0.02 is the relation between these variables. Now what we need is simplification. So using calculator, see this value 1.02 minus 0.02 divided by 1 plus 0.02. So you get something. And on simplification, I've seen that this value is 1.039. This is the value of y2. But you should know what is y2 means. Y2 means this is y of value of y at x2 means at 0.04. So y of 0.04 is here 1.0392. This represents y of 0.02. Question is y of point I need. So this step is over. Two more steps remaining. Next, go to this third step. We need y3. Y3 means y of 0.06 you have to find. How to get y3? The previous solution, that's y2 plus h into f of x2 comma y2. So y2 is written here plus h is 0.02 into f of x2 comma y2. x2 is here 0.04. Its solution is 1.0392. Once f of x is written, you know how it is related. For every problem it changes. So that relation you have to write. So f of xy, it is defined as y minus x divided by y plus x for this problem. So y means 1.0392 minus x 0.04 divided by 1.0392 plus 0.04. Simplify this. If you simplify, we may see that it is 1.0577. So that work you can do and check this whether it's correct or not. Randomly I'll return whether it is correct or not. I have not checked it. You also do yourself and see whether it's correct answer is there. So this is the value of y3. Now you have to go to y suffix 4 because we need the solution at a point 1. That's the question. So to get y4, the previous solution, that is y3 plus h into f of x3 comma y3. So this is very beautiful method of this solving this. That means the solution curve is represented by a straight line at that point. The previous solution plus that slope of the tangent we are adding. That's all. So y3 is here 1.0577 plus h is 0.02. F of this x3 means here 0.06, comma y3 means here return. Now just calculation work. This value is as itself plus 0.02. In this problem, again, f of x comma y is related like this. Y minus x divided by y plus x. So it is y, it is x. Simplify. Take your own time and simplify this value. And you may see that this answer is 1.0756. So this is the solution for this differential equation at which this one 0.08, this y suffix 4 at 0.08 again. But question is at 0.1. So one more step is that. So y suffix 5, that means the previous solution y4 plus h into f of x suffix 4 plus y suffix 4. As usual, y suffix 4 means this value plus 0.02 f of x4 y4. x4 is 0.08. This value is just return. Simplify. So on simplification, we get this value is equal to this relation, same relation. So it is 1.0928. So 1.0928 is the solution of that differential equation at the point x is equal to x5. That means x is equal to 0.1. So from that we conclude that the value of y at 0.1 is this value 1.092. There is a solution at that point. So that you can write. Therefore, the solution for the differential equation at x is equal to 0.1 is 1.0928. Here we are not mentioned because the question asked is to find y of 0.1. Otherwise, here also you can mention y suffix 4 is nothing but y of 0.04. This value is y of 0.02. Like that you can write. But this is the solution at that point. But this process of finding the solution is called Euler method. But what you observe is that it's very slow method and also it won't give a good answer for the problem. So later, Euler itself, that means Euler himself modified this formula and it is called modified Euler formula. So in the point of examination, give much important for modified Euler method, but for to modify, you should know what is Euler method. So in modified Euler method, what we do is, in every step, we modify the answer. So for example, we go to the previous step, say here, 1.02, what it represents, value of y at x is equal to x1, 1.02. But we don't know whether it's correct or not. Just simply written because by calculation you got it. It may not be the correct answer. It may be very far away from the exact root. This one just like assumed, that's all. So it is an approximate answer only. If the question is what the distance from Sulla to Mangalore, so say that some 90 kilometers or 87 kilometers or 89, everything is accepted because near to that. But instead of that, if you say it is 1000 kilometers, means no one believe that. You may say that you are a fool. You may tell like this. Like that here also, it's 1.02 means we don't know whether it's near to that or not. So how to improve this? For that, this modified method is used. So how to believe this means that we shall discuss in the next method. So here just it gives rough answer only 1.02, 1.039 to return, but we don't know whether you have to accept or not. So to modify this or improve the answer, we use the next method that is called a modified Euler's method. Let us see what is modified Euler's method. So this one, just modification of the answer, what the answer obtained Euler's formula, that we are improving. So improving that answer obtained in Euler's formula means here we need two formulae. One is to get an approximate solution by Euler's formula. Then we modify this. So that also done by Euler itself. So two formulae we use to find a solution by modified Euler method. So modification is only for the answer obtained from the Euler's method. Don't think modification is directly another formula, but it is modification of Euler's formula. So let us see how to do this. So here the process is in the previous Euler's method. What is done is we just replace that solution curve by a tangent, by a straight line. But here what we do is we take that average of the slopes of the tangents at the point x0, y0 and x1, y1 and take the average of this. So that is done by modified formula. So if you take the average value, how you get is first, so in Euler's method, what you have to notice that modified method, the solutions obtained in two stages. In the first stage, we find an approximate solution for the problem by using Euler formula. So what is the Euler formula? Y suffix n plus 1. That means the solution at the n plus 1th value of x is given by the solution at xn plus h into f of xn comma yn. This is the formula you have seen called Euler's formula. This one you have to modify. The answer at every stage we get when n is equal to 0, n is equal to 1, like that. At every stage we get this answer. At every stage we modify this using this modified formula. How it is modified means the same answer. Suppose that since it is an approximate answer, you put a star on the top. So yn plus 1 star means it is the value of y at a x is equal to n plus 1. But it is an only approximate answer. That is not good answer. That is obtained by predicting from this relation. So it is denoted by the symbol star here. While modifying, what to do means here you are taking the average value of the slopes, that is h by 2. So the modified formula is given by the value of y at x equal to n plus 1. This also at n plus 1. This also n plus 1. But this is only rough answer. This is good answer. To get it, the formula is yn plus h by 2. H by 2 means you are adding these two values and taking the average of this. So average is shown by this yn plus h by 2 into slope of the curve at xn, yn, that is f of xn, y1 plus slope of the curve at the next point, f of xn plus 1, comma, yn plus 1. But here also yn plus 1, here also yn plus 1. Which yn plus 1 means this yn plus 1 is nothing but value obtained by this relation, only approximate answer returned. You take the average value, that gives the good value for this. But again, how to believe this is correct answer or not? For that, it is treated as an iterative formula. In an iteration process, to get a good answer or exact answer, what to do is you have to go on doing this operation that is called iteration process. You have to stop the iteration when the stationary answer is obtained. Stationary means while doing this operation in two consecutive iterations, you get the same answer. In two consecutive iterations, if you get the same answer, you have to stop the iteration. Otherwise, you have to continue, just like a titration in chemistry, go on doing the titration till we get the exact answer. So this is what modified Euler's method. So give much importance for modified than Euler's method, because usually in the exam, they ask question from this part. We shall take one problem here. Suppose that this is a question using modified Euler's method. Find the value of y at x is equal to 0.1 from this differential equation. Dy by dx is equal to 3x plus y by 2 with the condition y of 0 is equal to 1. Here you have to note one thing, value of h is not given. When the value of h is not given, you are free to select the value of h. How you can select means, here at which point solution given, at 0 it is given, and I need the solution at 0.1. See the difference between these two. Take this difference is equal to h, so that in one step we can get the answer. But in the exam, if it is mentioned to take h is equal to some 0.05 means you have to proceed like this. Not mentioned means you directly take h is equal to 0.1. So in this problem, I will take h is equal to 0.1 because it is not mentioned here. So what is given here? X naught is equal to 0, y naught is equal to 1, and choose. Because we are free to select, I will choose here h is equal to 0.1. Next, identify what is f of x comma y. F of x y means the relation between x and y for the differential equation, that is 3x plus y by 2. So f of x comma y is 3 times x coordinate plus half of the y coordinate. Like that you have to treat. 3x plus y by 2 means 3 times of the x coordinate plus half of the y coordinate. That is how x and y related. Now, first step is where we need the solution. Since h is not given, you take h is equal to 0.1. So x naught plus h, 0 plus 0.1 means 0.1. So in one step, we get the solution. I mark this solution at x naught plus h as x1. So x1 is here. X naught plus h is 0.1. At that point, what is the value of y you have to find? First, we shall use Euler formula to predict the solution. So what is Euler formula? Y1, we need solution at x1. So y1 star, it is written, star means rough approximate answer. Euler formula is y naught plus h into f of x naught comma y naught. The formula written, y naught is 1, h is 0.1, f of x naught is 0, y naught is 1. So f of 0 comma 1. But here f of x comma y, how is defined? The relation is 3 times x plus y by 2. For use here, there's 1 plus 0.1 is there, 3 times x plus y by 2. So this will be 0 half only, 0.1 by 2 plus 1 means 1.05. This rest approximate value of y1, this method you have seen in the previous case, Euler's method. But here this modification not done. Now use modified formula to improve this answer. How the modification is done? So the value of y1 we need. So by using modified formula, value of y1 once again given by y naught plus average value of the slopes, that is y naught plus h by 2 into f of x naught comma y naught plus f of x1 comma y1 star, this value. So what is this? Y naught is 1, h is 0.1 by 2. It is x naught y naught, that is 0 and 1 plus f of x1 comma y1 star. X1 is this one, x naught plus h, it is 0.1 comma y1 star is written 1.05. Now you simplify this. It is nothing but it is 1.1 by 2 and here 3 times x plus y by 2. So for f of x naught comma y naught plus here f of x1 comma y1. That's again 3 times x1 plus y1 by 2. If you simplify, you may see that is y1 is equal to 1.06625. So whether you have to accept this or or reject. We don't know whether it's correct answer, correct or not, because modification is whether it's mod is done or not. How to believe? At the previous step, what the solution got using Euler's method 1.05. Here 1.06625 got. It's not very near. So if it is not satisfied, let us use this method once again. So if it is not satisfied, you again take this one as y1 star. Again, substitute in the modified formula. In using the modified formula, all this remains the same. Only change in the value of last value, that is y1 star. This is y1 star. It is actually f of x0 y0 plus it is f of x1 comma y1 star. In the previous one, you have taken 1.05. You replace this one by this number. Again, to use the modified formula to improve the answer. So again, using the modified formula, what to do is this value only replace here. No need of repeating all the steps here. So again, using what you get, this is the formula written, but all these are same. Only change in this value, this 1.05 replaced by 1.06625. See what the answer. If it is very near to this, accept it. Otherwise, once again, you have to use iteration formula. Here I got 1.06625. Once again, if you used it, I got 1.0665 means very near answer. So I accept it. This is the correct answer. So you can stop the iteration. So what is the solution? From that, we conclude that solution for this differential equation is 1.06652. This is the answer using this modified Euler method. So what is modification is must be known. Okay, now time is over. We shall continue in the next class.
Thank you, sir.
Okay, thanks.
Thank you, sir. Thank you, sir.